In this demonstration, I'll show you how to divide any two or more radicals. When it comes to dividing expressions that contain radicals, you have to keep in mind that the indices of the radicals must be the same in order for the division to take place. What is an indice? Well, first of all, indices plural form for index, and every radical has an index. That right there would be your index. Now, if it's not written, if there's not a number in that position there, we assume it's a 2. In this particular example, we have the square root of 4x to the power of 5 divided by the square root of 2x. Now, in a case like this, since the indices are the same, you can house them underneath one radical. And now you can divide the numbers. 4 divided by 2 is 2. X to the power of 5 divided by x is equal to x to the power of 4. So now you have the square root of 2 times x to the power of 4. Now keep in mind that when you have a radical and inside the radicand contains two parts, you can individually give those parts the radical itself. That being said, the square root of 4 is equal to x squared, and this remains the way it is, and your final answer is this. Now, you might be wondering, why is the square root of x to the power of 4 x to the power of 2? Well, here's why. Think of it like this. Let's pretend that x to the power of 4 was represented as x to the power of 2 to the power of 2, which is equally valid. And we know that the square root of a squared term, in this case x squared is being squared, is equal to x squared itself. Let's continue. Here we have 3 terms on the top divided by this one single radical term. If you ever run into a situation like this, you can distribute this square root of 3a to all 3 components above, where we get the square root of 3a to the power of 7 over the square root of 3a plus the square root of 12a to the power of 5 over the square root of 3a minus the square root of 6a to the power of 3 over the square root of 3a. Now, the really nice thing about this is that in each of these 3 terms, the indices are the same. They all have an index of 2. So in that case, we can ignore the radical for a second, and 3 divided by 3 is 1. A to the power of 7 divided by a is a to the power of 6. So we end up with the square root of a to the power of 6. Now we're not done. I'm going to reduce that later. 12 divided by 3 is 4. A to the power of 5 divided by a is equal to a to the power of 4, and that is also square rooted. And lastly, 6 divided by 3 is 2. A to the power of 3 divided by a is equal to a to the power of 2. Excellent. We can further reduce this. A to the power of 6 square rooted is equal to a to the power of 3. And in case you're wondering as to why that is, keep in mind that a to the power of 6 can be represented as a to the power of 3 to the power of 2. Right? Because 3 times 2 is 6, which is that. And the square root of any square term gives you a to the power of 3. In this case, we have 2, because the square root of 4 is 2. And the square root of a to the power of 4 is a to the power of 2. And lastly, this becomes minus a square root of 2, because a to the power of 2 is a perfect square, and 2 is square root of 2. And you can continue this by factoring out an a, because that's what's in common in all 3 of these terms, where you end up with 2a minus the square root of 2, and there you have it. Let's move on to the next example. Now notice that in all of these examples so far, the indices are the same. So in the last example, I'll show you one where the index do not match. In this case, we have a very simple example where we have 10 divided by 2, which is equal to, I'm going to house them underneath one big radical, 10x minus 5y, once again, 10 divided by 5 is 2, and x divided by y doesn't work, so you just write it out the way it is. And keep in mind that most of your teachers will not be content with this answer that you provide. And the reason why is because if you think about it very carefully, this expression represents this expression. Now, why is this expression incorrect? If you recall from one of the videos I created about rationalizing the denominator, mathematicians do not like seeing the square root at the bottom. So you'd have to rationalize this by multiplying the top and the bottom by the square root of y, which you would end up with 2xy square rooted over y, and this would be the answer that most teachers would be content with. Let's continue with the hardest example. Here we have two radicals that have indices that do not match. If you ever run into a situation like this, revert the radicals into exponents that are fractions. The cube root of a is the same thing as saying a to the power of 1 over 3. And the fourth root of b is the same thing as saying b to the power of 1 over 4. So what you have to do is you have to match the denominators. And the only way to do that is to multiply this by 4 and this by 3, because obviously what you do to the bottom you have to do to the top, and similarly here. And what we end up with is we end up with a to the power of 4 over 12 and b to the power of 3 over 12. Now the reason why this is good is because now we have an expression that looks like this. And notice the indices are the same, which is wonderful, because we can house them underneath one big radical, a to the power of 4, and here we have b to the power of 3. And once again, you end up in a situation that's not fully ideal. I mean, looking back, let's just remove this for a second. Let's just place it over here. It's not really that important. If you go back and focus on here, you'll notice that you have a radical at the bottom and you have to rationalize. And the only way to get rid of this radical is to multiply the bottom part by b to the power of 9 with a 12th root. Now you're probably wondering why that is. Well, since if we introduce this and multiply it to this, and they both have the 12th root, then you can multiply the radicands, and that will give you b to the power of 12. b to the power of 12 is a perfect 12th root, which would end up giving you b, and at the top you would end up with the 12th root of a to the power of 4 times b to the power of 9. And this would be the answer that your teacher would want you to provide. Now, if you have any more questions related to this video, please comment below, and if you found it helpful, you can support our channel by liking it or subscribing. If you need any more help with this topic or any homework help, use our website at biology-forums, which is located at the bottom right corner of this video. See you soon.